Okay, welcome to the very first edition of Mando tries to explain something he does not fully understand in an attempt to help you rudimentarily understand it, to hopefully make me understand it better. So, today we're going to be talking about desktops a little bit. Now, what I mean by this is sort of like desktop environments. So here I just have my regular Windows 10 desktop environment open. So this is what you're probably used to if you're a Windows user, and you might take this for granted. Just the UI elements here. Everything you see here it seems a little more complicated than I initially gave it credit for. And so the reason I'm thinking about this is because I've been playing around with Linux lately, and there's this thing called Wayland in Linux that sort of dictates how things are rendered on the desktop, and it sent me down a whole rabbit hole of trying to understand that. So we're going to start from the beginning to hopefully give a basic understanding of how stuff on your computer is shown off. So to start very basic, when your computer is going to show an image, it's talking to your graphics hardware. So it's immediately pinging your graphics hardware with certain commands, with certain instructions to get it to output a certain image. And so the sort of software used to talk to graphics hardware in an intuitive manner, that starts with graphics APIs. So we're gonna look at some graphics APIs. Here are just the most common ones you can think, or you might think of. So we're talking Vulkan, we're talking OpenGL. There's also DirectX from Microsoft. Basically, what a graphics API is it's a set of instructions and commands, and it's a standard for talking to your graphics hardware a certain way. So it is a standardized way to tell your graphics card to make images, and it's more complicated than that, and it renders everything from 3D stuff, games, all that kind of stuff. But essentially, that's how graphics APIs that's what their purpose is. So you want to show an image. The way you show that image is by talking to your graphics card. The way you talk to your graphics card is through an API that is standardized. So there's one code base, one set of instructions that talks to your graphics hardware a certain way to make it display images. One of the things you're going to want your graphics hardware to display is your desktop environment. So when you turn on your computer, the very first thing you see after you log in, any kind of menus you have, any icons, files, stuff like that, all of that is shown by your desktop environment. So the environment in which the stuff on your desktop lives. And you can render your desktop environment with these graphics APIs in a number of different ways. And so for Linux specifically, for modern Linux, there's two ways to really load these graphics APIs into loading your desktop environment. So the first major way is Xserver or x.org or xorg or whatever you want to call it. Xorg is what's called a compositor, I believe, where essentially it takes these graphics APIs and it applies them to creating your desktop environment. So Xorg has been the default for loading your desktop environment in Linux for the last 20 years or something like that. It's a very, very old code base. It's pretty legacy stuff. So it's sort of been evolutionarily built over the last couple of decades to be able to work with modern graphics hardware and modern graphics draw calls and stuff like that to render images on the screen, and for new visual stuff on your desktop. Xorg is sort of an aging code base, like I said, so Xorg is sort of out of style, so it's highly compatible right now with everything on Linux um, that renders any kind of image from your graphics card, but specifically with desktop environments. The problem with that is that it's so old that it's unoptimized and it doesn't work well with certain hardware. So like NVIDIA graphics cards work particularly badly with Xorg because the graphics driver, so um, the the plugin that essentially like lets your computer talk to the graphics hardware in the first place. The driver for graphics on Linux for NVIDIA cards is bad because they are proprietary drivers, so no one can contribute to them but NVIDIA, and NVIDIA is very slow to update their drivers, and so the drivers are just bad. But then on top of that, they have to deal with the Xorg codebase, which is old and unoptimized for like modern tasks like displaying. Like one big issue Xorg and NVIDIA have right now is you can't have multiple monitors displaying with multiple different refresh rates. So if you have a 120 hertz monitor and a 60 hertz monitor, it can only show one refresh rate across all your monitors, so everything will be 60 hertz, for example. So that's a limitation of Xorg, and it doesn't help that NVIDIA's drivers are trash. So what do we do to fix this? We create a new compositor for loading graphic stuff from these APIs, and the new compositor sort of proposed for Linux is Wayland. So Wayland has been in a sort of like alpha availability for the last like 5-ish years, it seems, and it's sort of only now starting to work really well with basic things like just opening windows looking correct. So like when you click on an icon, like when you click on your file explorer, like that opening up, that is part of your desktop environment making graphics calls. And so Wayland has only recently been able to like do this and like move windows smoothly, and stuff like that. Wayland is still using I think OpenGL for its baseline, but I think it's gonna involve Vulkan as its API at some point. Vulkan's just generally, Vulkan and OpenGL, the reason they're important as APIs is they are open source graphics APIs, so anyone can contribute to and use these APIs without having to pay any kind of royalties or anything like that, which is important. So Windows is unique because for doing stuff like this, it's using DirectX. DirectX is Microsoft's proprietary graphics API that they've been developing forever, for as long as they've had a graphical user interface. But it's Microsoft, so if you want to use DirectX stuff, you have to be running it on Windows for the most part, because Windows is the only operating system with DirectX plugins, or DirectX like stuff, and then you have to be paying royalties to Microsoft because you're using DirectX, or you have to pay for a license to use DirectX. So on the Linux side, they're using open source stuff like OpenGL and Vulkan. And so Wayland is the reason Wayland is important is because it's a new code base, and it's meant to be more optimized for like modern hardware, modern tasks, and it's meant to look sexy in the process. So it's meant to make window animation smoother. It's meant to like generally make the process of constructing your desktop environment graphically better, to my understanding. It's supposed to support modern features like high refresh rate and color settings and all that kind of stuff better in the future. It's currently in development. It does not support everything right now, but it has made significant progress in the last couple of years to where it's actually a viable, like you can run Wayland as your main desktop environment compositor, and not have any major issues. Also, Wayland is highly backwards compatible. So the Wayland, like the people at large, because Wayland is open source, and when a project is open source, anyone can kind of contribute to it and chip into the development. So the people that are working on Wayland understand that Xorg stuff is so heavily ingrained in the Linux ecosystem that those Xorg things still need to work. You can't just fully switch to Wayland, because if you switch every part of graphical rendering in the operating system and in your desktop environment to Wayland, it can't load everything, because there are simply not Wayland extensions for older applications, and older being just like, apps that have been written recently for Linux but that have not received Wayland support. So Wayland has an extension, I believe, called X-Wayland. Yeah, it's X-Wayland, and X-Wayland essentially runs Xorg commands within Wayland's like shell of codebase. So it has Xorg isolated within the larger Wayland compositor, and you can run individual Xorg instances and applications within a Wayland desktop environment. So it theoretically is supposed to be more smooth while still supporting all of the old Xorg stuff. And so I'm like, well, okay, how do I get Wayland going on my desktop, on my Linux desktop? I want to try out this new compositor. I want to see if there's anything different about it over Xorg. And I've messed with the old, with Xorg drivers and stuff in the past, like NVIDIA's Xorg drivers, and I'm like, well, let's get modern. Let's see what Wayland has to offer. And so something that I found great difficulty in was finding out distributions and desktop environments that support Wayland. So because Wayland is so new, everyone that makes a desktop environment and anyone that integrates that desktop environment into a distribution has to go out of their way to ensure that there is Wayland support. And if there is not, they have to add it manually. So they have to add Wayland's extensions and then make sure that all the backwards compatible X-Wayland stuff is working for all of their Xorg pre-existing code base. And if not, you have to kind of write things from the ground up. You have to like create new extensions for Wayland. Like if it's not just a drop-in thing, you have to like essentially create Wayland within a Wayland like instance within your desktop environment, to the best of my understanding. That's kind of a weird way to say that. But so I went looking for desktop environments and distros that have Wayland support. And so something that I'm sort of skipping ahead a little bit here, but something that sort of tipped me off to understanding how that works was when I just saw a video on Garuda Linux. So Garuda Linux is a distribution with a lot of different desktop environment choices. It's based on Arch Linux, so it's similar to like Manjaro, but it's prepackaged. It's sort of gamery, and it has a lot of desktop environment choices. And so when I was looking at the download page for Garuda Linux, I noticed that you start running these desktop environments. So their main desktop environment that they offer is KDE, KDE Plasma, and that, it's KDE, it's whatever. They have GNOME, so that's like Ubuntu, that kind of thing. The sort of more Mac OS looking desktop environment. XFCE, which was sort of like, which is similar to KDE Plasma. They're sort of like Windows 9XE. Like they have that kind of visual design, a start menu. They have all these icons on the bottom right, just like in Windows here. And then I sort of scrolled down LXQT. I don't know much about Qt or Qt. I have to look into that. But then I got down here to Garuda Wayfire, and immediately it says Wayfire is a 3D Wayland compositor inspired by Compiz and based on WL roots. Now I don't know what this is, but I see Wayfire is a 3D Wayland compositor. Bingo. And so that perked my ears. I was like, wait a second. Or I perked my ears when I saw that. I was like, wait a second. There's a distro here that is prepackaged with a desktop environment that is using Wayland, and it's being transparent about it. It's just saying it uses Wayland. And I scroll down, and another one, Garuda Sway. Garuda Sway is using Wayland. I'm just like, okay. All these other desktop environments, XFCE, GNOME, KDE are things I've heard of. I have not heard of Wayfire and Sway. So I just look up Wayland desktop environments. So here we go. So this is the list of compositors that are like based in Wayland. or that have some sort of Wayland development branch, or that are moving away from Xorg. And so in this list, I see right here, Sway and Wayfire. And it gives you a little bit of details, so it tells you the type of compositor they are. So there's stacking, tiling, there's stuff like that. So to the best of my understanding, tiling, you can actually see it here in Garuda. So Sway, for example, is a tiling-based compositor. That just means it has a status bar on top, and for window management, it tries to separate windows into tiles. So they are essentially like it tries to adjust your workflow by like moving windows into their own like part of the screen to like be snapped to, but not in the same way that like Windows, like Microsoft Windows does, like this. Like this is more like the traditional like so Wayfire does this. Wayfire is a stacking compositor. So what stacking tells me is that you're meant to be able to like open a bunch of windows and like stack them on top of each other and sort of move them around like this. When it's tiling based, it'll essentially like keep everything separate and like tile them into their own space here. So if this were tiling based here, these two windows would not be touching. They'd sort of be floating and be like separate and kind of blown up, if that makes sense. So I sort of learned something there. And then so I went looking through Sway and Wayfire, and there's a couple more compositors here based in Wayland. But yeah, so you can see Sway here. See how it kind of I'll make this big for you. It tiles these two windows. They're not separate, but they're not snapped either. So that there's these borders to clearly define where windows are. So see, there was a terminal window here on the right side of the screen. There's this browser on the left, and then there's a new terminal window on the bottom right here. And it keeps everything separate, and it has these gaps between windows to tell you sort of like where everything is, and without having to stack everything on top of each other or have to organize windows. Everything's just blown up. And so I think the main workflow here is you'll switch between virtual desktops to probably manage your windows that way. And most desktop environments have a virtual desktop setup where you can have multiple instances of your desktop environment to sort all your windows through. And then Wayfire here. I keep seeing the thing for Wayfire that says it is a 3D compositor, and they really mean that. So here in this Wayfire demo, they show the cube here, and so this is each side of this cube is a virtual desktop in the desktop environment, and so you can like turn it and sort of move between desktop environments. They also have some like nice visual effects here with windows. So when you open a window, there's this like fire effect. When you close it, there's another fire effect, and that's it seems like they have written that for Wayland specifically. Like that is a Wayland specific effect. I think something to do with the particles and stuff like that. And that happens with every window. And also when you like drag windows around, there's this like sort of morph effect that happens that I don't think is replicatable on Xorg, or at least is not done the same way on Xorg. But yeah, and so I was looking at all these environments that say they support Wayland, and I saw right here KWin. I was like, what's KWin? KWin sounds familiar. KWin right here, KDE Plasma KWin. KWin is the compositor within KDE Plasma. And KDE Plasma is the desktop environment that I'm using currently on my Linux box. I'm running Manjaro Linux with KDE Plasma 5.23 or whatever, so the latest KDE Plasma desktop environment. So KDE Plasma has this KWin extension that handles the compositor, the window management, and so it's dynamic. So I guess it's a little. I'm not exactly sure how this stuff works. The stacking, tiling, dynamic. I'm not 100% on this. So this is supposed to describe window behavior within the desktop environment. I don't 100% know how all that works. But yeah, so I see KWin, I see KDE Plasma. I'm like, okay, what am I running on my instance of Manjaro KDE? And so I look, and so there's like a settings menu. It tells you some basic info, so it tells you what kernel version you're running, stuff like that. And it was telling me, It says like graphics used, and it said X11 or the latest version of Xorg. So I was like, okay, how do I change it to Wayland? And so actually I haven't pulled this up here, but here, KDE. Yeah, so I was searching like how to make KDE run Wayland, blah, and so KWin Wayland, right here. There's this whole info page on the KDE community wiki about like what's up with Wayland on KDE essentially, and then there's people on the forums talking about it. I think there was so I think I was looking here on the Arch wiki. Here, I'll make this dark for you. So it talks about kind of graphics compatibility between with NVIDIA GPUs, stuff like that. And then here, okay, I just want to see if I can I want to see if I can replicate the sort of search I went on. Oh wait, where's my search here? Over here. Yes, lost track. KDE. Yeah, so I found some forum posts here. Make the start for you. And so they talk about this Plasma Wayland session. And so this command sudo pacman s Plasma Wayland session. So what you're doing here, so if you're in a regular X11 instance of KDE Plasma, and I think it applies to Arch-based distributions and Debian-based distributions. I'm on Arch, so this specific command, this pacman, applies to Arch. But basically, so what you need to do is, so KDE Plasma already has all of the built-in like stuff to do Wayland, but the default is X11 or Xorg. But you can make it do Wayland by essentially installing Wayland. And the way you can switch to it is not by like making some major configuration change or upheaving or removing X11. What you actually do is you start a new user session, as in like you literally hit like user icon log out, and then in the login screen before you log in on the bottom left corner there's start new session under X11, and then start new session under Wayland. So something I learned about the compositor setup is it's on the fly, so long as the operating system has the extensions to run the stuff. And so KDE already has all of the packages and extensions to run Wayland. You just need to install the Wayland session. So what you're doing here is sudo, which is super user to elevate permissions. Pacman is Arch's package manager. That to get the Wayland package. Dash S, I believe, is like to install. I don't exactly remember what dash S does. And then the package you're installing is Plasma Wayland session. And so all you have to do is install that single package that's missing for Wayland itself to run. And then once it's installed, you log out, select Wayland, log back in, Wayland. And so finally, I had this whole run around like trying to figure out how to get the Wayland session going. And once I got it going, it just worked perfectly. So what was really great about Wayland versus X11 on my installation of KDE Plasma was nothing was different. And that's a good thing because Xorg was working fine for me. And it was smooth and it was supporting high refresh rate. So I just have, it's a computer off to the side I have here. I'm using a 144 hertz monitor, but just a single monitor. And so it supported the high refresh rate just fine. The operating system like felt smooth, so something that can happen with using a whole new graphics setup for your desktop environment is some graphical elements can feel like slow, like some animations and stuff can feel slow if it's not optimized. So like just this like me clicking here to open my start menu in the corner here. When I click this, it just opens up. If the compositor is not optimized, that little action will stutter. I'm not sure exactly like where the like what the reason is that it's stuttering. If there's some graphics call that isn't optimized, or if it's part of like the infancy of like Wayland or whatever, but it can stutter. And it was a little slow for me, like the very first moment that I opened up the new Wayland session. But like once I gave it a second to like turn everything on, get the Wi-Fi on and whatever, it was just smooth. And so yeah, so that's really good because it means that Wayland is closer than not for prime time. And so hopefully it'll move the Linux desktop into um, a like trajectory of development for graphics stuff that is more future proof and that is not based on all of this old code base. So what Wayland means for the future is potentially better looking animations and stuff in desktop environments, and better support in the future for new graphics APIs, for new graphics like rendering techniques, stuff like ray tracing, for example. And it means potentially better driver support. So messing with your drivers in Linux, specifically for like NVIDIA, because NVIDIA's drivers are proprietary, should be less of a pain because of Wayland in the future. And so at some point, once everything's on Wayland, then like once the whole Linux desktop, like every desktop environment is running on Wayland, once every graphics driver is optimized for Wayland, once every application is being written for Wayland by default, like that's when Linux's graphics sort of flow for the general user gets simplified a lot, and that should help it to sort of compete with Windows on that front. Because Windows has the graphics thing locked down because of DirectX. So every version of Windows has certain API support to a certain extent for DirectX and all of its extensions. So Windows Vista, for example, was a big deal because it went up to I think DirectX 10. So there were certain games that ran under the new API and stuff like that. Certain programs that ran under the new API that you needed to be on Vista. I think XP got to like up to like DirectX 8 or 9, and then Windows 7 got up to DirectX 11, and then Windows 10 here gets up to DirectX 12 or 12.1 or whatever, 12 Ultimate. And so each new operating system supports more of the DirectX feature set, and that includes more graphical stuff, like as basic as high refresh rate, or as complicated as HDR, variable refresh rate, ray tracing. I think even like DLSS, stuff like that, like any kind of like special AI upscaling or downscaling is included in that feature set. Smart access memory, so the resizable bar support is the general name for it. So being able to talk to the GPU's memory directly from the PCI Express bus, rather than it like talking to the CPU and whatever. All of that is part of the like graphical feature set of the API and then subsequently of the like desktop environment. And so Windows has that locked down because of DirectX, and it's just Microsoft making it so they can, and they have the most customers. So drivers are the best on NVIDIA's drivers are the best on Windows, and everything is focused on DirectX. So there's no like disconnect the way there is on Linux, where like everything is old, everything is proprietary, everything's slow going on Linux for now. Specifically for like NVIDIA, and I mentioned NVIDIA a lot because NVIDIA is the like biggest player in the graphics space right now. Intel has not yet gotten a product out to the masses, and AMD is sort of playing a weird game where on Linux AMD's drivers are fantastic because they are unseen. So AMD actually has open source drivers on Linux. So there's drivers distributed by AMD by Radeon Technologies Group for your AMD graphics, but they are open source. So then what this community does, they look at AMD's drivers and they submit various adjustments, and then they repackage it as the Linux AMD open source driver. And so that will come pre-installed in every Linux everything because it's built into the Linux kernel. So it's built into the core of what makes Linux Linux. So if you have an AMD graphics card, chances are that your every part of the graphical pipeline is built into Linux. So it's completely unseen. There's no menus you have to mess with. Any optimizations have already been done for you, really. And then on the Windows side, it's complete opposite. So, so on the Windows side, AMD had a long and hard time getting their drivers to like even have a presence on Windows. So before Vega, even I'd say around like Polaris was when they started getting serious with their Windows drivers, in the sense that they started actually like serving them through Windows Update. They started actually doing like real things with the Relive software, or with features like Relive through the Radeon software, and even now their drivers are not as good as NVIDIA's. And they're, when you're served an AMD driver through Windows Update, it's still not as smooth as when you're served an NVIDIA driver through Windows Update. But they're getting better at it. But yeah, NVIDIA is sort of the king on Windows because NVIDIA's drivers on Windows are the best. They're the smoothest to install. They're the issues on the NVIDIA side are almost never caused by the driver, and if it is, it's because it's an old driver. Changing settings on the driver actually like does stuff. Managing settings is easier to like. It's easier to find what you're looking for in NVIDIA's driver settings. It's just NVIDIA is the king of graphics in the Windows space, but AMD has Linux totally locked down. And so hopefully fixing NVIDIA's Linux situation with Wayland will mean that NVIDIA can start to make sense for the general audience, because most people have NVIDIA graphics and most people want to still be running Windows because Windows is like their jam, or they're coming from a system running Windows and they're not expecting the graphics situation on Linux to be so much worse than on Windows. And so hopefully Wayland will iron that out over the next couple of years. So yeah, that's sort of my explanation, my thought process on everything here for Wayland and kind of what it is in the context of like graphics stuff. Again, this is a kind of half-baked explanation of my very basic understanding of some pretty complex shit for Linux. I hope this sort of made sense. If it didn't, I don't blame you, because it honestly doesn't make all that much sense to me. But yeah, I guess that's why we're here. So I'm going to keep looking into this. I'm going to keep playing with Linux, keep playing with new desktop environments, keep messing with Wayland, and we will see if I find anything cool. But yeah, I guess that's it. So I'll leave you here. I was trying something new here with the webcam. Hopefully you like it. I guess I'll see you around. Make sure to wash all of your pots and pans thoroughly.